Good morning. Here we are again. Now, if y'all don't mind, today we're going to be working on a Yaskawa Servopack SGDB-10ADG. Now, let's go in and see if we can figure out what the problem is. The very first thing we need to do is check the line and motor side against bus plus and bus ground to see if we have any short circuits. Let's get that out of the glare. There we go. Okay. Now I'm going to put our red lead on the N terminal. That's our bus ground. And our black lead on R. We have a diode drop of 0.526. Black lead to S, 0.526 volt diode drop. T with the black lead. Red lead still on N, 0.526. So far so good. Red lead on the N terminal. Black lead on U. 0.428 volt diode drop. Black lead to V. 0.428. Black lead to W. Red lead still on N. 0.428. So far so good. We might luck out and this be a good drive. Okay, now the black lead on the P terminal. Red lead on R. 0.526. Red lead on S. 0.526. Red lead on the T terminal. 0.526. The line side is good. The three-phase bridge rectifier is good. Now, red lead on U. 0.438. Red lead on V. 0.438. Red lead to W. There's our problem. We have a short circuit from the P terminal plus bus to the W terminal, 0.026. Let's go ahead and move the red lead to the B terminal. This is the black lead on P, the red lead on B. Alright, 0.062. Let's put our black lead, let's put our red lead back on the N terminal and go to the B terminal. 0.495. Okay, we're going to go inside and see why we have that short circuit from the P terminal to the W terminal. But there's our problem with this drive. Short circuit on the motor side. First thing we're going to do is take this cover off. We have these plastic clips right here. Raise up one side. There's that. Be careful not to break those plastic clips. I've done it before. There's that side. Oh, it felt like the other side clipped back in. Oh, there we go. Okay. Now we got the cover removed. Set this over here. Let's take the connector off. We'll undo these screws right here. Different screwdriver. That one's not biting. There we go. Okay. Now there's a couple of clips here. What I'll do is I'll unclip this side, and then rotate it a little bit. There's our control board. Okay, I'll set that to the side. Now here's the power supply section. We want to remove this cover right here. In order to do that, there's a couple of screws down here that we need to undo. Let me look down in there. That one might be missing. No, it's there. Okay. Let's take this screw out first, then we'll get that one. There we go. Magnet to get those screws out of there. Okay, now we can take that ground clip off. Let's see if we can get that one out. Come on. It's not magnetized, so I gotta pluck it out. There we go. Okay. Now, once again, we have to undo these clips. There's two in the back, one on the side, and one on this side. So I'll get the sides first. Just leave that one in there so it don't re-clip. Side. Okay. Don't fall out. Don't fall out, screwdrivers. Now we'll undo the back. Alright, we're in. Get my screwdrivers out of the way. There we go. Let's move these covers out of the way. Okay, here we are. It's pretty complicated in there, isn't it? Here's our IGBT right here. 7MBR30NF060. We'll find out if this is the cause of our short circuit when we get down there. Let's undo our connectors. Okay, now we'll take this assembly off the board. This is our power supply right here. This makes the voltages for the control and the voltages for the IGBT firing channel. Let's undo our bus capacitor. Now before we do that, let's make sure that capacitor is discharged. Let's put our meter into volt mode. Black lead on bus ground. Red lead on bus plus. We have 0 volts DC. We're good. We're not going to get ourselves lit up today. Let's undo this bus capacitor. The wiring. All right. Now there's 4 screws here, 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 and here that need to be removed in order for us to pull that assembly off the board. Parts bucket for those screws. Alright. There we go. There's our power supply. I'm going to run these bus capacitor screws back in so I don't lose them. Okay, we'll set this down here with the covers. Now the next thing we want to do is remove this board right here. It's really nice the way they did this. We have little feed-through connectors right here, state connectors coming up from the power board. And there's a couple over here too. So we need to be concerned about making sure that the state connectors go back up into the feed-through connectors. There's 2 connectors right here, thermal and fan wires. We need to undo those. Let's see if we can get these connectors out of the way. This is what brings the voltages from the power supply down to the gate firing circuitry. Get that one out of the way. It's little tabs you have to push in to unlock it from its mating connector. And we got that one out of the way. Now, we can leave that one on there. Let's undo our screws. I'm going to get another parts bucket for these screws. Try to keep my screws separated so that when I go to put this back together, I won't have to figure out what screw goes where. And if I can, I'll reinstall the screw. Is that everybody? Appears to be so. Okay. Get these wires out of here, they're holding us up. Okay. There we go. Now we have that board removed. Here's our 2 current sense modules. Here's the wires that go up to the bus capacitors. set that board down there with the other boards. All right, we're at the point where we can test our IGBT. Here are the terminals for the IGBT: R, S, T, B, U, V, W. Here's P, P, and N. Let's start out by putting our red lead on N, our black lead on R. We have 0.525 volt diode drop. Whoops. Black lead on S, 0.524 volt diode drop. Black lead on T, 0.524 volt diode drop. Here's B, 0.842 volt diode drop. Here's U, 0.427 volt diode drop. V, 0.427 volt diode drop. And W, 0.427 volt diode drop. Now let's put our red lead on P. Let's see if the two P's are tied together. No, they're not. So let's put our black lead on this P, and we'll go red lead to R, 0.525 volt diode drop. S with the red lead, 0.524 volt diode drop. Red lead on T, 0.524 volt diode drop. Red lead on B, okay, that's OL. U is OL. V is OL. W is OL. Let's move our black lead to the other P. Okay, here's R, OL, S, OL, T, OL. Get on there. B is 0.052. Let's see if that's a resistor. Yeah, 51.5 ohms. That's a resistor. Okay. Not a short circuit, it's a resistor. Okay. Let's go to U. 0.427 volt diode drop. V. 0.427 volt diode drop. And W. 0.426 volt diode drop. Where'd the short circuit go? Where did the short circuit go? It's gone. Oh, here we go. This is going to be a mystery here. Let's find out what the mystery is. We had a short circuit when the drive was fully assembled from the P terminal to the W terminal. But now we don't have the short circuit. What did we take off the board that removed that short circuit? Huh. Well, let's do some ciphering here. This is the part of troubleshooting that I like, where you get a mystery like this, and you have to solve the puzzle. Okay, we know the short circuit is not in the IGBT, so let's move this out of the way. And we'll bring this board back into play. Let's look at this board here. See what we can find. Now it looks like here is 3 diodes, power resistor, another resistor over here. How many ohms is that resistor? 2.5 ohms for this resistor. 10 ohms for this resistor. Let's check those resistors since we're in here. Yeah, that resistor's good. 10 ohms exactly. Let's check this one. 2.6 ohms. That's a good resistor. Now we're going to check these diodes in this TO220 package. There's 3 right there. Let's find out. See who the cathode is. Does the board say who the cathode is? Who's the cathode and who's the anode? Okay, anode's on the right, cathode's on the left, and the part number, if I'm reading this, let me get my close-up glasses on. We'll read the part number of that diode right there. Part number of the diode is D8L60. Okay. Let's flip this board over. Let's put our meter into diode test mode. Anode on the right, cathode on the left. That diode's good, 0.402. That diode's good, 0.399 volt diode drop. That diode's bad, 0.007 volt diode drop. There is our short circuit. The IGBT is good, the diode is bad. We can fix this one. All we have to do is get us a replacement diode. Let me go hunt around the shop and I'll see what we can find. We got old drives like this laying around. I should be able to find a diode off of one of them. I'll be back in a little while. Y'all take you a break. And we'll get back together here after I do a little bit of hunting for that diode. Found a replacement diode in the North 40 on an old blown up Yaskawa drive. This is a good one right here. I'll set that aside and we'll take the shorted diode off the board. Tight fit between those current sense modules and that power resistor. Let me add a little bit of solder here. Help the old solder flow. Now I'm going to see if I can rock this out. Try to rock it back and forth until it falls out. And then we'll remove the solder from the vias. Almost there. There we go. There's the bad one. Let's check it out of the circuit. Yeah, that's shorted. 0.004 volt diode drop. Get this in the... Yep, there you go. That's a shorted diode right there. That was the downfall of our drive. Now let me set this way over here so I don't accidentally put it back into the drive, thinking I'm putting a good one in there. See if we can get the old solder out of the via. Quite. Let's see. I have to turn the heat up on the iron. Yeah, I need to turn the heat up on that iron. There's too much surface area here for it's soaking up the heat of the iron. There we go. Got that one. At least on this side. Not sure about the other side. We'll look in a little bit. Yeah, got that one. All right. Now we want to absolutely make sure we don't put this diode in backwards. That'd be just as bad as a short circuit. Get my flashlight. Okay, cathode on the left, anode on the right. Let's turn this around. Cathode on the left, anode on the right. Let's go ahead and check that one, make sure it's good before we put it in. Cathode on the left, anode on the right. Come on. There we go. Ah, I'm on it now. 0.441 volt diode drop. That's a good diode. We'll go ahead and install it on that board. It's a tight fit down in there. Not sure if I'm going to be able to get this in there very easily or not. Add some light on the subject here. Too many things in the way. I got it. No, not yet. Come on. I have to turn the camera off so you all don't get to hear me cuss. Oh, I got it. I got it. Okay, don't slip out. Okay, don't slip out. Get my solder. I'm holding it with my finger so it don't fall out. There's that one. There's that one. Okay, let's check it again. Okay, got our meter in diode test mode. Let's check this one up here again. 0.381, 0.365, 0.402. That's a good one. Okay. Now, let me clean up the back side of that board. And you want to know something? I am really curious what those diodes are doing in the circuit. Let's say we map that circuit out and we find out exactly what the function of those diodes is. Let me clean up that board and we'll work that circuit out on paper. Hopefully it won't be too difficult to do. We'll see. I've got that circuit mapped out with the 3 diodes, but before we look at that circuit that I've drawn out, let's take a look at what's inside that IGBT power module. Here's the 3-phase bridge, R, S, and T inputs. Here's the high side diodes and the low side diodes. The high side diodes connect to the P terminal, and then the low side diodes connect to ground, bus ground, the N terminal. So here's the 3-phase bridge. Now on the motor side, P1, this is why we had to move our leads when we were diode checking the 3-phase bridge and the motor side. So when we checked the 3-phase bridge, we went black lead on the P terminal, red lead on R, S, and T. But on the motor side, there's no connection here. We had to move our black lead to P1 and then test B, U, V, and W with the red lead. Now, on the bus ground side, the N terminal, is connected all the way through on the 3-phase bridge side to the IGBT motor side. So, keep in mind the P terminal and the P1 terminal when we go and look at my drawings. I'm upside down and turned around backwards here. But let's get oriented here. First off, here is the connections. It's labeled on that board TMP, but it goes to the P terminal of the IGBT three-phase bridge power module. That is on the three-phase bridge side. TMP1 labeled on the board goes to the P1 terminal on that IGBT power module, and that is on the IGBTs of the motor side. So here's three-phase bridge side, and here's motor side of the positive rail of that IGBT. Here's the bus capacitor. It's 680 microfarad at 400 volt. Here's that fuse. It's 30 amp DC 400 volt fuse, part number CR2LS-30. Now, what's going on here? You'll notice that our three-phase bridge is connected to the fuse, and it comes up here through the 10 ohm resistor over to the bus capacitor and the positive rail of the IGBT motor side. So what we're doing in effect here, when this relay RY1 is open, we are pre-charging this bus capacitor through that 10 ohm resistor. And at the point where this bus capacitor is charged, this relay will close, and the contact will bypass that pre-charged resistor. Now, what happens when the relay is de-energized and in this position up here? Let's move over here to the second page. Let's see if I can get in the frame here. This is where it gets pretty interesting. Are we there? Now, I'll put these drawings up at the end of the video so you can make copies of them if you want to. But down here is the IGBT U, V, and W terminal. Now on the board, it's labeled TMU, TMV, and TMW, and that goes to U, V, and W of that IGBT. Here's the terminal connections out to the motor. So you would connect your motor here on the terminals, TB1, U, V, and W. Now here are the diodes. Part number D8L60. There's D1, D2, and D3. And this diode right here was shorted. Now you remember that 2.5 ohm resistor, that 20 watt resistor that we measured. I think it was 2.6 ohms measurement. That connects these three anodes of these diodes back to that circuit we just looked at. We'll get back there in just a second. But notice that the cathodes of this D3 diode goes to W. The cathode of this diode, D2, goes to V. And the cathode of D1 goes to U. Well, what are they doing there? Let's go back to our first page. Let me see if I can get this in. Can I get it all in one picture here? Maybe, most likely not. We gotta move everything down. We gotta get this back in the picture here. Okay, so this point right here, when this relay is de-energized, the bus capacitor is connected to point A. Now this snubber circuit right here prevents these contacts right here from arc welding together when this relay is energized. That's what the snubber's for. It prevents arcing of the contacts. But here, the bus capacitor and A, point A right there, goes to this 2.5 ohm resistor. So imagine if we had that bus capacitor right here, and we had the DC voltage applied to the anodes of these diodes. Now that DC voltage will be connected to the windings of U, V, and W, and that's going to stop that motor from rotating. Is that crazy? It's fascinating. So there's our circuit. I'm going to put this up at the end of the video so you can take pictures and make copies of this circuit right here. If you ever have to troubleshoot that circuit, you'll know what's going on. Just remember, this is your IGBT right here, U, V, and W. This right here is the P terminal on the three-phase bridge side, and this right here is the P1 terminal on the IGBT motor side. There we go. Let's put our drive back together. Now, I'm sorry to say, we're not going to be able to run that drive because I don't have the motor. If you don't have a motor connected to this drive, it comes up in an alarm saying that the feedback is disconnected. But let's put our drive back together. Give me a little bit to drag everything back up here. All right, we're going to go back together. Here's the 3 diodes down here that we replaced one of them. Gotta get our state connectors lined up. Okay. We got that state connector and this state connector lined up and connected. After we get it back together, we'll check UV and W, RS&T to the P terminal and the N terminal with our meter again. Now, let's hook up our bus capacitor. Black wire to the ground side of the bus capacitor. Red wire to the positive side of the bus capacitor. Double check, make sure everybody's tight before we put the lid on it. Okay. The plastic clips are engaged. Keep forgetting I'm not right-handed. Come on. My left hand don't work too good anymore. There we go. I seem to have lost a screw. If I ever had it. Okay. Look for that screw. I'll find a replacement someplace. See it on the ground over here. Okay, here's the control board. Now what I do is there's a little peg right here in the hole. I'll get that that peg in the hole of the board, then swing this around, get under that lip, and then press down on this side. And that usually takes care of orienting that board properly. Okay, we have our control board mounted to the housing. Let's close this connector. All looks good. We'll install the cover. Get in there. There we go. Make sure we're clipped in. That's good. That's good. All right. Let's test our UV and W. And RS and T to the P terminal and the N terminal. Try not to get in the way of that meter display. All right. Switch arms right here. All right, black lead on P. There's R, 0.523. S with the red lead, 0.523. T with the red lead, 0.522. Black lead still on P. Here's B, that's our resistor, 0.062 diode drop. Here's U, oh, stay on there, 0.436 volt diode drop. V with the red lead, 0.436 volt diode drop. And here, this should be good now. Yes, 0.435 volt diode drop where it used to be shorted. Now, let's put the red lead on the N terminal. Here's R, 0.523, S, 0.523, T, 0.523. Let's go to the P terminal. 0.793. Here's the B terminal with the red lead on N, 0.835. Now, red lead on N still. Here's U, 0.425 volt diode drop. V, 0.426 volt diode drop. And W, 0.426 volt diode drop. Well, folks, it looks like you fixed another one. Awesome job. Awesome. Y'all did good. Now, I'm going to power up this drive and we'll look at the alarm code that comes up because we don't have the feedback connected to the 2CN connector. We'll get an alarm. We'll see what that alarm says. Give me a little bit to bring the cable over here to hook up 220 volts AC 3-phase to RS and T. Alright, we're going to hook up our line to RS and T, and I have these jumper wires to connect R to little r and T to little t. Now, let's hook up. Now, little r and little t power up the control, and R, S, and T power up the DC bus for the motor. Don't fall. Don't fall out. Let me get this up here so it don't fall out. Okay, there's R. Let's jump R to little r. Now here's S. Is connected. Here's T. Get in there. Oh, I am going to get aggravated. Something to hold that white wire down so it don't keep popping out while I'm trying to put this red wire up into T. There we go. There's T. And we're going to jump T to little t. There we go. Okay. Install our display. Alright, we'll plug our line into the wall. Let's double check our connections. There's R, S, T, little r, little t. Here we go. There's a cooling fan spun up. And we have the alarm AC2. AC2 occurs when we don't have the feedback connected, the feedback from the motor. Let me power down and we'll get close to that display and you can take a look at it. There's our alarm, AC2. AC2 occurs because we don't have the feedback connected from the motor to the drive on the 2CN connector here. But I know it would run if it was in the machine connected to that motor. Y'all did good. You've resurrected another one from the dead. Let's get on out of here and have you a good day. And we'll see you in the next one.